We're going to skip section 4.7 and 4.8, which is translations and scale changes, and go right to 4.9, which is the culmination of those two together. So this is what the problems will be like more so on the test. So let's look 4.9a. Write an equation of sine or cosine given an image or a rule. So here we have, suppose we have the transformation, and they've combined here a translation and a scale change. So we have x minus pi over 2, 5 times y. If this is applied to the graph of the cosine function, write an equation for the image. Well, let's go ahead and do the equation, and then from that we'll come up with these other specific answers. All you need to do the equation is write down the parent function, which is the cosine of x. And remember, when we go to the x, and if it's minus pi over 2 to the x, it means when I come to the x, it's plus pi over 2. It's always backwards for the x in the equation. Now for the y, it's always the same once it's written on the same side. So this is y times 5. So over here, I'm just going to put a times. And this right here is the equation of the graph. Now from that, let's state the amplitude, period, phase shift, and vertical shift. Remember that the adding and subtracting is the phase and the vertical shift. The phase shift deals with the x, the vertical shift deals with the y. So when we look at the ordered pair rules, we have x minus pi over 2. Now this is exactly what's going to happen to the graph. It is going to shift left pi over 2. So the phase shift here is going to be left pi over 2 units. Now if you look at the y, there's nothing added or subtracted, so the vertical shift is 0 or none. Now the amplitude and the period here, those deal with multiplication and division. And again, the amplitude is going to impact the y movement, the period impacts the x movement or the stretch. So what we see for the amplitude is with the y. And what you do is if here's y is times 5, so the order pair is literally what we see happening, so the amplitude is actually going to change to 5, which means each hump will be 5 units high or 5 units low. Now the period is impacted by an x stretch or shrink. So if you look at the x, it's not being multiplied or divided by anything. So what is the period of the cosine function? That is, if you were to sketch the cosine function as a parent, how long does it go until it starts the same pattern over again? It goes to 2 pi. So the period of the cosine is 2 pi. If we look at this next one, here's the transformation this time. It's 3 times x, and it's y plus pi. So again, we have a combination of a stretch on the x, so the multiplying or dividing, which means it's amplitude or period. And we have an adding or subtracting here and adding to the y, which means it's a phase shift or vertical shift. So let's start and actually write the equation first. And now we're starting with the sine function. So here's our parent, and what I'm going to do is the ordered pair rule is always going to be backwards in the equation for x only. So not x times 3, but x divided by 3. So I'm going to be very specific and write it like that. And the same thing for the y that we see in the equation, so it's y plus pi. So at the end here, I'm just going to put plus pi. And make sure when you write the equation that the pi is not looking like it's with the x, so very much so put parentheses around this. Now let's go ahead and actually talk phase shift and vertical shift. For adding and subtracting, there's only one component, it's with the y. Now the ordered pair rule is literally what's going to happen to this graph. So this graph is going to stretch horizontally 3 times, and it's going to shift up pi units. So if you think about it, a phase shift is going to be right or left. A vertical shift is up or down. Now because we're adding pi to the y, that's vertical. When you add, we're going to go up. So here we're going to go up pi units. There is nothing being added or subtracted to the x, so in terms of the phase shift, there is no phase shift. Now amplitude and period, the amplitude is going to be the multiplication or the division on the y, in which there is none here. So the amplitude, be careful, what's the normal amplitude of our parent functions? The amplitude is typically 1 unit high. Now the period is impacted on the x-axis, and it's a stretch or multiply or divide. Here they're taking the x and they're multiplying it by 3. So be careful. The only time you do x backwards is in the equation itself. When you answer all of these questions, all of these words match up with these ordered pair rules. So the period is going to be 3 times larger. So you must first start and say, what is the period of the sine function? Again, how long does the sine function go before it starts to repeat itself? It's 2 pi units long. But we're going to take that and times it by 3. So come on in here and times it by 3. So the new period of this function is going to be 6 pi. The key thing you want to take away from this learning objective is the ordered pair rule is literally what's going to happen to the graph, so it should match all of these vocab words. The equation itself is the only thing that's going to have it be backwards is the x movement. Other than that, it's all the same. 4.9b wants us to graph the image given the sine or cosine equation or rule. In this case, they've given us the equation. So the one thing about the equation, again, we have to be careful. All the x stuff in the equation is backwards. Everything else on this slide should match up and be exactly what's going to happen. So let's first break down the translation rule and the scale change rule. Those two rules will help us come up with these 4 vocab. So first thing I need to do is when I look at this equation, the translation and the scale change rules are this. The translation rule is going to say what's happening to the x and the y. Again, translation means the add or subtract. The scale change rule is what happens to x or y. And again, that's going to be our multiplying or our dividing for that. So let's start with the scale change rule. That's the easier one. So if we look at this, we know that the scale change means a stretch or multiply or divide. So here we have that x is being multiplied by 2, but in the equation, everything is backwards for the x movement. So it's not x times 2, it's going to be x divided by 2 for this. Now the y is always the same. This number here, the 7 is the multiply that's left over, and it's not with the x, therefore it's a y. And what we're going to have here is going to be 7y. So what's happening to this graph, it's going to shrink horizontally in half and stretch vertically 7 times. Now the translation rule, the y movement is the easier one to start with here. So let's actually do that first. If we look in the equation, the y movement's always the same when it's on the same side. Translations add or subtract. This is plus 2, so that's plus 2. Now here's the one thing you have to be careful of. If you look at what's happening to x in this equation, what we see is that 2x has pi over 2 subtracted from it. But I need to know what's happening just to x, because look at this, it says just what's happening to x. This is 2x. So you must factor out this 2 to see how this changes. So to factor this 2 out, let's pull it out of the x and write it here. And notice I've pulled it out of the x value. But because this is all in one group, I have to pull the 2 out of here. The easiest way to do it, because I pulled the 2 out of here, to pull the 2 out of here, just multiply the bottom by the 2. And it's going to be minus then pi over 4. Now you can actually see if you're correct, you would just go ahead and do the distribution. 2 times x is 2x. 2 times negative pi over 4 would simplify to negative pi over 2. So this is correct. Now when it comes to reading the x translation rule, you're going to go into the equation, look what's happening just to the x. Again, we factored out the 2. And you always go backwards, so it's plus pi over 4. Now from there we can fill in the necessary words. Let's do the phase and vertical shift first. Remember, everything here is going to match up. It's just the x movement in the equation that's backwards. So the phase shift means left or right movement to the x being added or subtracted. So on here we're going to go right pi over 4. And then for this one it's y plus 2, and on the y-axis plus would be up 2. Now the amplitude and the period, they come from the stretches, so let's do the amplitude first. Here it comes from the y, so the amplitude of the humps are going to be 7 units high. Now the period we have to adjust. The period of this is a sine function. The period is typically 2 pi. but it's going to change. What's going to happen is the x is going to be divided by 2. This is going to be divided by 2, so the new period is now pi. So to sketch this by hand, what I first recommend is doing the parent function for the sine, and then do it alphabetically. Come in and actually do the stretches or the scale change rules, so change the amplitude and period. Once that's done, come on in and do the translation, which is the phase in the vertical shift. When there's 4 things going on, sometimes people make a mistake if they do the shifts first and then they do the stretches. So let's go ahead and just do the parent function of the sine graph. So from 0 to 2 pi, do just a rough sketch of sine. And that's what it looks like. Now let's come on in and in the blue, come ahead and do the amplitude and the period. So the period used to be from 0 to 2 pi, but now it has to go from 0 to pi. So I have to make that same S shape from 0 to pi. But I know the humps of the S shape is actually going to become 7. So what I'm going to do is actually extend my graph out a little bit more to give me a 7 there and down here. And I'm going to go in and make my S shape go like that from 0 to pi. So it's going to go from 0 to pi. It's going to cut here. Between 0 and 2 pi it maxes out at 7. Between pi over 2 and pi it minimums out at negative 7. So if you connect those, we have that type of graph. Now I'm going to come in and finish this thing up and actually do the phase and the vertical shift. So I'm going to take these key points right here, these 5 key points that were drawn on the scale change, and move each of them. I'm going to go right pi over 4 and up 2. So if I take this blue point and I go right pi over 4 and up 2, I'm going to land right there. So that's where that moves to. And I'm going to have to extend out my graph again a little bit more. Let's take this guy right here, which is at pi over 4, and move right pi over 4 and up 2. So this is going to be right here. This graph, right pi over 4 and up 2, for that point is going to be right there. This point here, right pi over 4 and up 2, brings me to the negative 5. And the last point, take this one, right pi and up 2 is going to land me right here. So now when you connect those points, you're going to include the translation, and the red graph is our final image. Now here they did ask me to do 2 cycles of that, so I could go ahead and draw it one more time, and here's what it would look like. In this green portion is the second cycle of the new graph. Learning Objective 4.9c wants us to state amplitude, period, phase, and vertical shift, and all the translation and scale change rules, given an equation or an image. Here they have an image for us, and they want us to state all of the information and give the actual equation. So they are telling us our parent function we're starting with is the sine. So where I first start with this is I get ready to write the equation, and this is really the last thing I do, but I know the parent is going to be the sine of x, so I jot that down. Now I go over here to the graph paper and I sketch 1 cycle of the parent function. So sine goes from 0 to 2 pi. That's the number 1 there. So that's what it looks like. Now the key here is to try to mimic that same shape. Notice how sine is. A nice even symmetry of a hump on the top and a hump on the bottom. So where do I see that symmetry happen? There's actually 2 different places, and I'll show you both equations, but the first one that I see as I want to trace it out is I see the sine function right here as 1 cycle. Those match up. So what I do is I start to compare the red and the blue graph, and I do this backwards. I fill all this information in first, and then I do the scale change and translation rules. So let's start with the period. The period of the original sine function is 2 pi. This one goes from 0 to 4 pi, so I'm going to write that down for the period is 4 pi. Now the amplitude, this hump is 1 and 1, or the way to find it is the distance. So you go from here, the distance between 2 and 0 is 2, cut it in half, it's 1. Each hump here is 1 unit high. So really the amplitude didn't change. Now there is a translation here, did it slide? You want to do is you want to find the starting point of the sine function, which is right here, and you want to travel and see where it moved to. It looked like the parent function slid up 1. Well, that's a vertical shift of up 1, and it looks like that the phase shift is 0. So from that, I can write the translation rules. The translation rule for this is nothing for the x's, but the y is +1. The scale change rule for this is be careful, nothing with the y because that's the amplitude. But for the period here, we do have to adjust it. The period is 4 pi, so what did they do to it? Well, it was the original period times some value gave us 4 pi. All you really need to do is solve the algebra. If you divide by 2 pi, you're going to notice the a value, or the stretch on here, was 2. So what they did is they took the x's and they multiplied them by 2. Again, notice all of this stuff flows together with the picture. So everything on the screen right now is exactly the same thing. When we do our final step of writing the equation, the only thing that's backwards is the x. So we're ready to do that. Let's go ahead and do the scale change first. I need to go to x and not multiply by 2, but divide by 2. Nothing here for the y, so no multiplication or division. There's no add or subtract to x, but on the y I do the same thing, so it's +1. And that's the final equation for this graph. Now I do want to highlight something you may have seen. You may have saw that this was also another sine shape, or the S shape, and that would work. If you did that, the period on this is still 4 pi, so that didn't change. The amplitude is still 1. The vertical shift on this, if we go from the original starting green point of the red graph to this starting green point, you're going to notice it still moved up 1, so the vertical shift did not change. Only the phase shift would change in this case. So what would happen to this graph is you'd go from this point up 1, and notice we are going left 4 pi. So what you could have also said is you may have said that the phase shift was left 4 pi. So if you did that, what the equation would look like is slightly different. You would still have your parent function. Let's start with that. You're still going to take x divided by 2, and then you're still going to have the y is the +1. Now the only difference is, because this time we said that there was a phase shift, if we change this in the ordered pair rule, it would have been x minus 4 pi. And then we have to come to the equation and not do minus 4 pi, but plus 4 pi. So here in the purple is also an acceptable equation for this problem. Again, notice in the purple, everything on the screen flows except for in the equation. We had to not go left 4 pi, but we had to say plus 4 pi to make it work. Here's a second one. Again, they are giving us the sine equation here to start with. Here's what it looks like. They want to know what the equation is. So I'm just going to jot down again the parent function and then go back to the graph and sketch out one cycle of the parent. Sine is from 0 to 2 pi at pi, and it's going to max out and bottom out at 1. So we have this parent function right here. So then I want to go to the graph that they gave me and actually sketch out the same symmetric portion of sine. Again, there's a variety of places we can go, but here's where my eye first goes, is I see that this movement here and then that right there. So let's compare the red and the green graph to fill in the vocab. I'm going to start with amplitude and period. The period of the parent is 2 pi. The period of this starts at pi over 2 to 3 pi over 2. So the period is 1 pi unit. The amplitude, the original hump height is 1. This guy goes from a positive 1/2 to negative 1/2. The distance is 1. Divide that by 2, you get a half. Or notice the heights here are a half. So the amplitude is 1/2. Let's go ahead and just write the scale change rule for that. Well, the scale change rule would say that the amplitude is 1/2. So what I did is I took the y's and I divided them by 2. Now again, be careful with the period. To get the period, they took 2 pi and they times it by something, and here they got 1 pi. What did they actually divide it by? Because that is the stretch that I want to put right here. You can do the algebra if you want to do that, if you can't see it. You're going to notice the pi's cancel, so the stretch on here is 1/2. So what they're doing is they're taking the x's and they're dividing them by 2. So what's happening to this graph is it's shrinking horizontally 2 times and shrinking vertically 2 times, which we can actually see from the red to the green. Now let's go ahead and do the phase shift and vertical shift. So I'm going to grab one of the key point here on the sine function is right there in the parent, which we go to here now. If I notice, it looks like I move right pi over 2 units. So the phase shift here is right pi over 2. There is no up or down movement, so there's no vertical shift. So the translation rule for this is going to be x plus pi over 2 and y. So we have 3 things going on in this graph. Well, we can go ahead and write that. So what I'm going to do first is, why don't I go into the x, and instead of x plus pi over 2, again, always go backwards, it's going to be x minus pi over 2, and group it to show that it's with the x. Now, here it's x divided by 2, so in the equation you must go backwards and you have to multiply that by 2. And then the last, it's y divided by 2, or if you want to look at it this way, it's y times 1/2. So what you can do is you can come in here and do 1/2. So there's a couple ways you might have this final equation. You might have y equals 1/2 sine of 2 and then x minus pi over 2. Notice where the parentheses are. You may also have chosen to multiply this through. You don't have to, but if you did, you would have the 1/2, and then you would have sine of 2x minus pi. Now do note there's one other way you could have written this. This 1/2 here, what you could have done instead is you may have chosen to do sine of 2, and let's say you kept this in parentheses here. You could take the whole thing and divide it by 2. So all of these are acceptable answers. Again, the takeaway from this learning objective, everything on the screen flows together except for the x movement here within the equation.